Alright, we're still talking about the inverse tangent function, and we're going to do some examples. We're told here, find angles with the following tangents. So A is 0.431. So we want the angle whose tangent is 0.431. So that would be the inverse tangent of 0.431. So on the calculator, we'll do inverse tangent of 0.431. And press enter. It's 23.32 degrees. So let's write that. 23.32 degrees. Okay, find the angle whose tangent is 7.95. This should be an angle that's larger than 45 degrees. So we do the inverse tangent of 7.95, enter, and we get 82.83. Okay, so yeah, that was bigger than 45, as we would expect. 82.83. Now the inverse tangent of 1, the angle whose tangent is 1, you should know that that's 45 degrees. Even without a calculator, you can put it in if you want to. The inverse tangent of 1, and it better say 45. If it doesn't, your calculator is faulty. But there it is, the inverse tangent of 1. The angle that has a tangent of 1 is 45 degrees. Okay, how about 2? The angle that has a tangent of 2. The inverse tangent of 2 is 63.43 degrees. Okay, how about the angle that has a tangent of 0? That ought to be 0 degrees. Let's just put it in. The inverse tangent of 0. And it's 0. Okay? And then the next one is the inverse tangent of 0.1. Okay, hit the wrong key there. Inverse tangent of 0.1 is 5.71 degrees. So that's the angle that has a tangent of 0.1. Inverse tangent of 0.01 should be even smaller. So the inverse tangent of 0.01 is 0.57 degrees. 0.57 degrees. Now watch this, the inverse tangent of the square root of 3. You can type it into the calculator like that. The inverse tangent of the square root of 3. So the square root is the second function on the x squared key on this calculator. So the inverse tangent of the square root of 3, and look what we get, nice round number, 60 degrees. And that might ring a bell to you. When we were talking about 30, 60, 90 triangles, the tangents of particular angles, we found that the tangent of a 60-degree angle was always the square root of 3. So the inverse tangent of the square root of 3 is always 60 degrees. This is an example of one that you can do without a calculator. So some of these you would know and be able to figure out without a calculator, like this. The angle whose tangent is 1 is 45 degrees, and the angle whose tangent is 0 is 0 degrees. The angle whose tangent is the square root of 3 is 60 degrees. But some of these you can't do mentally like that. Like I wouldn't expect you to know that the angle whose tangent is 7.95 was this. So some of these you would have to rely on a calculator to do. Okay, here's a more practical example. We're given a triangle here. Okay, it's a right triangle. You see the right angle right there. And we're given this angle here, or we're shown this angle here, alpha, and we're told to find alpha. We're given the lengths of the sides. Now watch this. I know that the tangent of alpha will have to be the length of the side opposite alpha divided by the length of the side adjacent to alpha. So 3 over 4. The tangent of alpha is 3/4. Okay, that's 0.75. So if the tangent of alpha is 0.75, then alpha will have to be the inverse tangent of 0.75. And we can do that on the calculator. Let's pull this up. Okay, the inverse tangent of 0.75, and there it is, 36.87 degrees. I just found this angle. All I knew were those sides, but using that and the inverse tangent function, I can find the angle. Because I know the tangent of the angle has to be this over this. If I know the tangent of the angle, then I can find the angle with the inverse tangent function. Now I want you to note also that we don't have to divide this number and then do the inverse tangent. We can do it in one step, and this is good to be able to do in one step. Watch this. I don't even have to write this, but I would think the tangent of alpha is 3/4, so alpha is the inverse tangent of 3/4. And I'll put it in my calculator like that. Instead of dividing this first and getting 0.75 and putting 0.75 in there, I'll go ahead and put the ratio in there. The tangent is 3/4, and I can put 3/4 right into the calculator like that. So watch this. The inverse tangent of 3/4. And it should give me the same number. There you go, 36.87. Another example, we're told to find beta. Okay, we'll look at beta. It's right down here. That's this angle. So I know that the tangent of beta will have to be the length of the side opposite beta. So which side here is opposite beta? Well, if we go from angle beta across the triangle, we get this. So the side opposite beta is 4.27 divided by the length of the side adjacent to beta. That's 1.75. So tangent of beta is 4.27 divided by 1.75. Let's do that on the calculator. 4.27 divided by 1.75. And I get 2.44. So the tangent of beta is 2.44. Well, if the tangent of beta is 2.44, then beta has to be the inverse tangent of 2.44. And that we do on the calculator. The inverse tangent of 2.44 is 67.71 degrees. Okay, and again, you should be able to do this in one step. You should be able to work it like this. And you don't even have to write this part. You can just, in your mind, take note that the tangent of beta is 4.27 over 1.75 because you're looking at the diagram and you're saying, okay, the tangent of beta is 4.27 over 1.75. So beta must be the inverse tangent of that. So beta would be the inverse tangent of 4.27 over 1.75. And you could type that into the calculator just like that. See here? Inverse tangent of 4.27 divided by 1.75. And press enter, and it will say 67.61. Exact same answer, 67.61 degrees, rounded. 67.71, excuse me. 67.71 degrees. So doing it in one step like this is a little faster and efficient and less error prone because you don't make a mistake in this calculation accidentally, or you don't make a mistake typing that in there. The calculator just does it here, and you also don't get any rounding error. In some cases, this number might be rounded and you're putting in a slightly less accurate value here. So doing it in one step avoids any rounding error. The calculator will, in its memory, do this calculation as accurately as it can. And then one more comment about the notation here. If we have this, the inverse tangent of, say, 0.5, okay, that would be the angle whose tangent is 0.5. This notation that looks like an exponent, to avoid the confusion of it looking like an exponent, some books use this notation, arctan. And it means the same thing. Arctan means inverse tangent, but you don't have this confusing little -1 that might be mistaken for an exponent. I will mostly use this notation just because that's the most common. Most textbooks, by far the majority of the textbooks, at least the ones that I've seen, and I've seen a lot, use this notation. But you should know this. You do run into that from time to time, especially in computer programming. If you do any work in programming computers, computer programs are just written in all text, and that's kind of hard to type. But this is easy to type, and it means the same thing. Arctan is the same thing as inverse tangent. So if you're reading another textbook or seeing a presentation in a classroom or on the web or something like that, and you see this notation, just know that that means the same thing as that, inverse tangent. And when people say arctan, that's what they mean. They mean the inverse tangent.